Now the next effect is mesomeric effect or resonance effect. Resonance effect or mesomeric effect. We can say that. So, what is resonance effect or mesomeric effect? You first write the definition. The flow of electrons from one part of the conjugated system. The flow of electron from one part of the conjugated system to the other part, creating centers of low and high electron density. Creating centers of low and high electron density. Creating centers of low and high electron density due to the phenomena of resonance is called resonance effect. Due to the phenomena of resonance is called resonance effect or mesomeric effect. It is also called R effect or M effect, capital R or capital M. It is also called pi-pi conjugation effect. It is also called pi single bond pi conjugation effect. So the flow of electrons from one part of the conjugated system. Conjugated means where alternately single and double bond is there. That is said to be as conjugated. We can say that. So system to the other, creating centers of low and high electron density from where the electrons will flow to the other where the electrons from the part from where the electron flows to the part where the electron is flowing. So from the part where the electron flows, that part creates a center of low electron density. And to the other part where the electron is flowing, it creates centers of high electron density. We can say that. So low and high electron density is being produced. That is said to be as what? That is known as mesomeric effect or resonance effect. It is pi-pi conjugation effect. It is known as. Alright, that is said to be creating centers of high and low electron density. We can say that. So it is also of two types. It is also of two types. That is plus M effect and minus M effect, or plus R effect and minus R effect. We can say that. Alright. So here plus R effect is that, right? Plus R effect. What I said? Plus M or plus R effect. The first one is. Second one, minus M or minus R effect. So first one you write plus R or plus M effect. Groups which donate, this one, the first one. Groups which donate electrons to the double bond. Groups which donate electrons to the double bond or to a conjugated or aromatic system, or to a conjugated or aromatic system is said to have plus R or plus M effect. Groups which donate electrons to the double bond or to a conjugated or aromatic system is called plus R or plus M effect. We donate electrons to the double bond. The group we donate electrons to double bond, remember that, is said to be have plus R or aromatic system. We can say that. Also we can say conjugated aromatic system. It's said to have plus R or plus M effect. So which groups it is? It can be OH group, it can be SH group, it can be SR group, got it? It can be OCH3 group, etc. In this way we can have so many, we can have it. Cl group, Br group, I group, Nr2 group, single bond Nr2. In this way so many we can have it. So that it comes under, what is that? Plus R or plus M effect. This group donates electrons to the pi bond, got it? Or to a multiple bond, we can say that, or a conjugated pi system. Now next is your minus R or minus M effect. Group which withdraws electrons from the double bond. Groups which withdraws electrons from the double bond or from a conjugated system towards themselves due to resonance is said to have minus R or minus M effect. Towards themselves due to resonance Groups which withdraws electrons from the double bond, groups which withdraws electrons from the double bond or from a conjugated system towards themselves due to resonance, is said to have minus R or minus M effect. So here the groups which donate electrons. Here in case of minus R or minus M effect, the groups which withdraws electrons. Alright, see, always donation is taking place by single bond and withdrawn always takes place by multiple bonds. Alright, so here it can be, the multiple bonds can be, it is nothing but C double bond O, then CHO, then COOH, then COOR, in this way. All these are multiple bonds, withdraws electrons. Alright, or from a conjugated system, which withdraws electron from the conjugated system. Alright, towards themselves due to resonance is said to have minus R or minus M effect. We can say that. Clear? Now let me give an example for your plus M effect. Let me give an example. Now CH2 double bond CH single bond Cl, let us say we are having it. So here that is Cl, so it will give this and it will give this. Alright, so here you can see towards the conjugated system, towards this is. So as a result, what it happens? CH2, here a pair of electron comes, CH single bond, this one is CH2, sorry, CH2 it is. Then that is single bond CH, then double bond Cl. We can say that a pair of electron comes here, isn't it? So it is positively charged. We can say creating centers of high and low electron density is called as what? High and low electron density. This is high electron density, this is low electron density. It's plus R or plus M effect, we can say that. Clear? Now this is your minus M effect. CH2 double bond CH. Same example I am taking, just this I am changing it. So what will happen is that here, that is this group will withdraw electrons towards itself. It withdraws electrons towards itself, we can say that. That is C here, CH, C triple bond N, we can say that. CH, wait, just a moment. That is CH2 double bond CH, single bond C, triple bond N. Yes, this is correct, more correct. This one is, yeah, now this is more correct. So in this way. So as a result, it will be CH2, here single bond CH, then single bond C, double bond. It is negatively charged, and here it is, what is that? It is nothing but double bond comes here, and it is here positively charged. So this is the plus one is, the first one is plus R or plus M effect, and second one is minus R or minus M effect, we can say that. Alright, in this way. Now the difference between the mesomeric effect and the resonance effect is that resonance effect already we have studied in chemical bonding I have taught you. So that is mesomeric effect is based upon chemical considerations. Mesomeric effect is based upon chemical considerations. This is, but resonance effect is completely theoretical. Alright, that's the difference. Resonance is completely theoretical. It exists only in pen and paper. It is completely theoretical. Moreover, the essential conditions for what you can say mesomeric effect is the presence of multiple bond. We can say that in the molecule. But in the what you can say in resonance effect, what you find is that it is not necessarily the multiple bond has to be there in it. Alright, it may or it may not be. We can say that. Like HCl exhibits resonance, but not mesomerism. HCl does not contain a multiple bond. It can exhibit resonance, but not mesomerism. We can say that. Clear? So, phenoxide ion is resonance stabilized. Alright, phenoxide ion is stabilized by resonance. So, there are many compound where we need to, what you can say, many radical, many compound is there where we need to say about the stability of the compound. There we use a phenomenon of resonance, because there the theoretical and the practical concept does not match. So, there we use a phenomenon of resonance to what you can say the stability, to make you understand about the stability of the compound. You have studied in the other chapters also. We can say that this is resonance stabilized, this is resonance stabilized. We say that means this is stabilized with resonance, means where we cannot have any what you can say, a particular structure cannot help you in understanding the complete concept of the molecule or complete properties of the molecule. Then we use the phenomena of resonance. Alright, and the resonance structure lies in between all the canonical structures. Canonical means similar structures, equivalent structures. It lies in between these canonical structures or a similar or equivalent structure. That is a resonance structure, which explains all other properties of the molecule or all the properties of the molecule. We can say that. Got it? So we have discussed all about it earlier. So I'm not coming to it now. Now this is about a resonance and the mesmeric effect. The difference I said, that is, mesmeric effect is based upon chemical considerations, but resonance effect is completely theoretical. We can say that. Now next is hyperconjugation effect. The next effect is your hyperconjugation effect. Hyperconjugation effect, we can say that. The inductive effect of the alkyl group on a saturated carbon chain, you can write it down. The inductive effect of the alkyl group on a saturated carbon chain, follows the order. What is that order? 3 degree is greater than 2 degree, is greater than 1 degree, is greater than methyl. I told you just now what is 3 degree, 2 degree, 1 degree. 3 degree means one carbon is attached to 3 other alkyl groups, and 2 degree one carbon atom is attached to 2 other alkyl groups, and 1 degree means one carbon is attached to one alkyl group. We can say that. So in this way, the inductive effect of the alkyl groups on the saturated carbon chain follows this order, that 3 degrees greater than 2 degrees greater than 1 degree greater than methyl. I told you just now in the plus I effect. Alright. However, when an alkyl group is attached to an unsaturated system, such as a double bond, or a benzene ring, the order of inductive effect is actually reversed. The order of inductive effect is actually reversed. This effect is called hyperconjugation effect, or Baker-Nathan effect. Baker-Nathan effect. It is said to be as hyperconjugation effect or Baker-Nathan effect. We can say that when an alkyl group is attached to a benzene ring, or when an alkyl group is attached to a unsaturated system, that is to a multiple bond, to double bond or triple bond, we can say that. Then the order of this particular order, that 3 degree, 2 degree, 1 degree methyl, it is reversed. Reverse means what it happens? Methyl now is greater than 1 degree, is greater than 2 degree, is greater than 3 degree. Alright, the order is reversed. So this is said to be as hyperconjugation effect. We can say that. Now let me give an example to you so that you will be clear. So here this is an alkyl group, you can see. This is an alkyl group and this is your multiple bond, an unsaturated system. We can say this is a multiple bond. Alright, so here you can see very clearly that is an alkyl group attached to a multiple bond. So what is going to happen? So here this pair of electron will come here, and as a result this pair of electron will come here, because you can see it here. Here carbon atom 4 bonds, here carbon atom 4 bonds, here carbon atoms 4 bonds. So when this pair of electrons is being borrowed by this carbon, so this carbon becomes 1, 2, 3 bonds. It is not satisfied. So hence this pair of electron comes here, either this or this or this, anyone, it comes here. So as a result, what you get it? You get it in this way. Here that is double bond, here CH, single bond CH2 minus, we can say that. So this particular H plus ion does not have any bond with this carbon atom. Does not have any bond with this carbon atom, this H plus ion, we can say, which is being formed. But it is attached to this carbon. It cannot leave the electron cloud of this particular carbon atom. So hence, this is also called as no bond resonance. It is also called as no bond resonance. How it is resonance? Because it takes place from this hydrogen atom. I can take this hydrogen also. I can take this hydrogen also. So hence, number of canonical structure it shows. Try to understand. This I have taken out. This is okay, fine. Now this, the shifting of electrons is taken has taken place from this bond. Why? I can't take this one. I can take this one also. I can take this one also, this bond also. This pair of electron can go ahead, this pair of electron can go ahead. So as a result, it can form H plus ion, it can also form an H plus ion, it can also form an H plus ion. So 3 canonical structure we can get it. So when we get number of canonical structure, then what is called, that is resonance structure. That is known as a resonance structure. So as you can see, H plus ion cannot leave this carbon atom. It is attached to the electron cloud of this particular carbon atom. It comes under the influence of the electron cloud of this particular carbon atom. So hence it is called as no bond resonance. For that reason, no bond. Bond is not there, but still then it's a resonance structure. So it is known as no bond resonance. So hyperconjugation occurs through hydrogen atoms present on the carbon atom next to the double bond. That is alpha hydrogen atom. This alpha. This is the double bond. This is a functional group carbon atom. These two carbon atoms are functional group carbon atom because double bond is there. So after the functional group carbon, the next carbon atom is known as alpha. If you are having another one, that is known as beta. If you have another one, that is called as gamma. In this way we come. So always the hyperconjugation effect takes place with the alpha hydrogen atom. See, this is the alpha carbon atom. So the hydrogen atom attached to it is known as alpha hydrogen. So it takes place with the alpha hydrogen atom. The shifting of electron takes place from the alpha hydrogen atom. We can say that. Alright, so understood? Due to this shifting of electrons, due to this no bond resonance, the order of the inductive effect is reversed. It is reversed. Now the order is this. It gets reversed when the alkyl group is attached to a, what you can say, conjugated, that is system, or to a benzene ring. Got it? The order of the inductive effect is reversed, and we get a number of canonical structures here. Got it? So here the H plus ion is not attached to this particular carbon atom, alpha carbon atom, but still then it cannot leave the site of this particular reaction. So hence it is known as no bond resonance. I can show it in benzene ring also. I can show you in case of benzene ring also. I can show you. I don't have this little bit smaller one. I'll make it. I think you can see it. So now here what will happen, this is your benzene. Now this pair of electrons will come here, so this pair of electron will go outside. So as a result, a canonical structure you will get it here. Here this pair of electron, you can see this carbon hydrogen, and this H plus ion is here attached to it, and this is. Now we can have another structure is that this will come here. Now this is, it forms a double bond of course. Now it can come here, alright, it can come here, and here we'll have H plus ion, or it can come here and we'll have an H plus ion here. Alright, I think you're following. So this is called as hyperconjugation effect. This effect is known as hyperconjugation effect, so to say. So now due to hyperconjugation effect, what it happens, that we'll see next. Thank you.